Hello dear students, welcome back to Physics Online Bridge course classes. So in last class we discussed about errors, and in case of that errors we got that information about that systematic errors as well as random errors. So in case of systematic errors we come to know that because of the definite reasons we are getting errors, so those errors are belongs to systematic errors. So whereas certain kind of errors will get occurs while measuring the physical quantity, so we don't know that proper reasons for that getting errors. So such kind of errors we can call it as random errors. So in case of random error, in order to minimize the errors, so we can use some mathematical tool. For example, so we will consider about absolute error. So mean absolute error we can consider, relative error and percentage error. So in order to measure that any physical quantities, it involves certain kind of individual physical quantities. For example, I want to find out that area of cross section of that any material, whatever you can take. So in order to measure that area, so for example length into breadth, so two terms are required. Means while measuring the length we are getting certain kind of error. So right, while measuring the breadth also we are getting certain kind of errors. Then what is the total error in measuring that area here? So did you get my point? So look at here. Here area generally I can take it as length into breadth. Okay. So while measuring that area of that any object, so we will measure length of that object as well as breadth of the object. So look at here. While measuring the length with the help of instrument, we are getting certain kind of error here. While that measuring the breadth also, we are getting certain kind of error. Then what is the total error occurred in case of that area here? I want to find out in the similar way. So for example, I can consider that force value. So force is equal to what? Mass into acceleration. I want to measure that mass here. So in order to get that force value, I have to measure the mass here. While measuring the mass, you will get certain kind of error, right? And as well as while measuring that acceleration also you will get certain kind of error here. Then what is the total error in case of that force I want to find out, or similar way. So this one is multiplication example, or look at here. Final velocity is equal to initial velocity plus acceleration into time. So in order to measure the final velocity, so first I will measure initial velocity. While measuring initial velocity I will get certain kind of error. While measuring the acceleration also I will get certain kind of error, and while measuring the time also I will get certain kind of error here. So look at here, while measuring that individual physical quantities I am getting individual errors here. Then how to find that total error in case of force and in case of area as well as in case of that velocity here? So in order to understand such concepts, so we will discuss about that combination of errors here. So look at here, in that any physical quantity, so I want to measure that total error present in that physical quantity. So in order to measure the total error, so we will understand about that combination of errors. So today's session, so we will be discussing about a combination of errors. So look at here, combination of error. So in case of combination of error, we can consider that so errors will get occur in case of addition of physical quantity, subtraction of physical quantity, and as well as in case of multiplication, and as well as in case of division here. So look at here, in physics we are deriving lot of formulas here. So while deriving the formulas, it involves that individual physical quantities. While measuring that individual physical quantity, we are getting individual errors. So I want to find out what is the total error here. So in order to find out the total error, we will consider about combination of error here. So in that combination of error, so I can find out combination of error in case of addition and in case of subtraction and in case of multiplication as well as so division here. So today we will be focusing on combination of error in case of addition and subtraction. So first I will consider here combination of error in case of addition. So we will focus on combination of error in case of addition here. So for example, I am having one physical quantity. So for example, suppose Z is one physical quantity. So I will take, suppose Z is a physical quantity. Z is a physical quantity. So this physical quantity is obtained by making addition of X and Y here. So Z is a physical quantity obtained by adding X and Y. So look at here, I will generally take one formula related to addition here. So Z is one physical quantity. So this physical quantity will get while measuring X as well as Y here, X plus of Y. So treat this is one general formula here. Now I can consider that while measuring the physical quantity X, I will get certain kind of error, and while measuring the physical quantity Y also will get certain kind of error. Then what is the total error will get in case of Z I want to find out. So did you get my point? So in order to get that physical quantity Z value, I have to measure physical quantity X as well as I have to measure physical quantity Y here. While measuring X, I will get certain kind of error, as well as while measuring Y also I will get certain kind of error. Then what is the total error in case of Z I want to find out. So for that purpose, let delta X and delta Y be the absolute error. So I hope you remember about absolute error. So look at here, delta X and delta Y be the absolute error of X and Y. So look at here, what I consider here, delta X and delta Y be the absolute error of X and Y. For example, in order to consider the physical quantity X, so you are making number of trials, X1 plus X2 plus means X1, X2, X3 up to X of n. Number of trials you are going to consider. First you find out that mean value. So X1 plus of X2 plus of X3 divided by n here. So then you will get mean value or average value. Then how to calculate that absolute error here? So it is the difference of, so what I consider, so it is the difference of mean value to the observed value I said. So A bar minus of A. So that is, so for example, X bar minus of X1 I can consider like that. So while measuring that physical quantity X and Y, I am getting absolute errors are delta X and delta Y be the absolute error of X and Y. Then shall I take that X is equal to X plus or minus of delta of X. So I can consider, so while this is the total physical quantity while measuring the X, so delta of X will be the its absolute error. So X I can consider as X plus or minus of delta of X, and Y I shall consider as Y is equal to Y plus or minus of delta of Y. So did you get my point? So next I will consider so Z is one physical quantity, right? So in case of that Z, we are getting delta of Z be its absolute error. So look at here, where delta of Z be the absolute error of Z here. Then Z shall I write it as a Z plus or minus of delta of Z here. So I have X value, Y value and Z value. Then equation 1 becomes here. So I can rewrite here, equation 1 becomes. So look at here, equation 1, wherever Z is there, I will write it as a Z plus or minus of delta of Z. Z plus or minus of delta of Z. So that is equal to wherever X is there. So I can take it as X plus or minus of delta of X plus of wherever Y is there. So I will take it as Y plus or minus of delta of Y. Y plus or minus of delta of Y. So I have to simplify this equation. Z plus or minus of delta of Z is equal to, so I shall rearrange here. So Z X plus or minus of delta of X plus Y plus or minus of delta of Y. Shall I rearrange in this way? X plus Y plus or minus of, so I can consider X plus Y plus or minus of delta of X plus of delta of Y. So that is equal to z plus or minus of delta of z. So now I have to find out what is the maximum possible error in measuring the physical quantity z here. So maximum possible error is, so delta of z is error I can consider. So maximum possible error is delta of z is equal to what? Delta of x plus of delta of y. So look at here, this is the maximum possible error while measuring the physical quantity z here. So delta of z is equal to delta of x plus of delta of y. So remember here, what's the conclusion I will get it here? So from this equation I can conclude that, so combination of error in case of addition. So in case of addition, so maximum possible error it is equal to, so maximum possible error it is equal to sum of the individual errors. So maximum possible error is equal to, so maximum possible error is equal to sum of the individual. So you can consider while measuring the physical quantity x, you will get certain kind of error. So that one, and as well as while measuring the physical quantity y, we will get certain kind of error. So that is delta of z is equal to delta of x plus of delta of y here. Now I will consider that error in case of subtraction here. So I got in case of addition, I got that equation here. So similarly, I want to find out that what will be the equation for combination of error in case of subtraction here. So combination of error in case of subtraction. Okay, suppose I will consider the same physical quantity. Suppose z be the physical quantity obtained by subtracting. Just I will change here. Subtracting x and y, then then z is equal to what? X minus of y here. So look at here, while measuring the physical quantity I will get that error here. So that error is delta of x be the absolute error while measuring that x, as well as delta of y be the absolute error while measuring the physical quantity y here. So then I can consider that x value as x plus or minus of delta of x, y plus or minus of delta of y, and while measuring the physical quantity z plus or minus of delta of z. Then equation 1 I can rewrite as, so look at here, so then equation 1 I can rewrite as, so wherever z is there, z plus or minus of delta of z, and wherever x is there, x plus or minus of delta of x minus of y plus or minus of delta of y here. So now I have to simplify this equation. Z plus or minus of delta of z is equal to x plus or minus of delta of x minus of y. So plus or minus of delta of y I can consider. Shall I write this equation as x minus of y? So that is plus or minus of delta of x plus of delta of y I can consider. So z plus or minus of delta of z is equal to what? So z plus or minus of delta of z is equal to x minus of y. So x minus of y plus or minus of delta of x plus of delta of y here. So look at here, I can consider the same thing. Delta of z is equal to what? Delta of x plus of delta of y. So look at here, so maximum possible error is, so I can write this one as maximum possible error is, so delta of z is equal to delta of x plus of delta of y. So don't get confused here. In case of addition also I said delta of z is equal to delta of x plus of delta of y, whereas in case of subtraction also I am saying that delta of z is equal to delta of x plus of delta of y. So I can conclude that in case of errors, errors are always additive in nature. So why? Because, so just you may think by yourself, while measuring the physical quantity I will get certain kind of error. So while measuring the physical quantity y also will get certain kind of error. What's the total error? If you subtract the error also, means if you subtract it means you won't get that what is the total error here. So total error becomes 0. So it is not possible here. So look at here. While measuring the physical quantity, you will get certain kind of error. While measuring the physical quantity, y also will get certain kind of error, means so total error in case of z will be more here compared to x and y. Why? Because you are getting two physical quantity x and y. While measuring x also will get certain kind of error, while measuring y also will get certain kind of error. Then total error is always additive in nature. So remember one point, errors are always additive in nature. So just here that x minus of y is there. So but error is always additive in nature, means total error we can able to find out. That is, errors are always additive in nature. Additive in nature we can consider. Errors are always additive in nature. So I will give an example, then it will be somehow clear for you. For example, I will solve some numericals related to this one. So in case of combination of errors, we took that combination of errors in case of addition as well as in case of subtraction. So in both the cases I got that delta of z is equal to delta of x plus delta of y. It means that errors are always additive in nature. So for example, I will take two wires, those two wires having the resistance here, two wires of resistance. So for example, two wires of resistance. So for example, one wire I will consider. So for example, 100 plus or minus of 3 ohm. So look at here. So 100 is a resistance. So plus or minus of 3 indicates its error here. And another one is 200 plus or minus of 4 ohm. So I will take two wires here, two wires having the resistance 100 plus or minus of 3 ohm, 200 plus or minus of 4 ohm. So 200 ohm is the resistance. So 4 indicates that. So errors while measuring the resistance of the second wire. Then find the total error. Find the total resistance. Find the total resistance in series combination. Series combination. I hope you got that basic information about that resistance are connected in series combination formula. So it's in SSLC syllabus. So that is R of S is equal to R1 plus of R2 here. So it is example for Z is equal to X plus of Y. So now look at here. R plus or minus of delta of R is equal to what? R1 plus or minus of delta of R1 plus R2 minus of delta of R2 here. So now I can find out that what is the total resistance here. So in order to find out that total resistance, so this is the connecting formula I said. So this is the connecting formula, means so I want to find out that. So total resistance R is equal to R1 value is how much? 100 plus or minus of 3 plus of R2 value is how much? So 200 plus or minus of 4 here. So then what is the generalized formula? A plus B. So R1 plus of R2, or I will make more generalized here, so don't get confused here. R1 plus or minus of delta of R1 plus of R2 plus or minus of delta of R2. R1 plus of R2 plus or minus of delta of R1 plus of delta of R2 here. R1 is how much? R1 is 100 ohm. Okay, right. R2 is how much? So that is 200 ohm plus or minus of delta of R1 is how much? 3. Delta of R2 is how much? 4 here. So what is the total resistance here? 300 plus or minus of 7 ohm. Look at here. So what is the error occurred here? Total error occurred in case of series combination is 7 ohm. What is the total resistance here? 300 ohm. So look at here. While measuring the first wire, I am getting that error as 3 ohm. While measuring the second wire, I am getting error as 4 ohm. Then what is the total error get occurred here? That is 7 ohm here. So simpler thing. So similarly, I will consider initial temperature and final temperature of the water baths are. So look at here, initial temperature and final temperature of water bath is. So I will consider one container here. In that container water is there, so I will take that initial temperature and final temperature of the water bath is. So initial temperature, so let it be 18 plus or minus of 0.5 degrees Celsius, and final temperature is 40 plus or minus of 0.3 degrees Celsius. Find the rise in temperature. So which thing I need to find out here? Find the rise in temperature. How much temperature will get rise here? So what is the connecting formula in order to find out that rise in temperature? So final temperature minus of initial temperature. So that is common sense formula. So rise in temperature. How much temperature will get rise here? So final temperature minus of initial temperature, if you do, means I have to consider what is the temperature, means how much amount of temperature will get rise. I want to find out easily. So rise in temperature is equal to final minus of initial temperature. So in order to find that rise in temperature, so for example, T is equal to final temperature, means I can consider T of F, initial temperature is T of E. What is the final temperature? Or I can consider in terms of error, I can consider T of F plus or minus of delta T of F minus of T of I plus or minus of delta T of I. So initial temperature. So what will be the connecting formula? I will get it here. So that is, so T plus or minus of delta of T plus or minus of delta T plus or minus of delta T. Shall I take that T of F minus of T of I, final temperature minus of initial temperature, plus or minus of T of F plus of T of I. So delta of T of F plus of delta of T of I here. T plus or minus of delta T. So T of F is how much? 40 minus of initially is how much? 18 here. Plus or minus of, means delta of T of F is how much? 0.3 plus of T of I is how much? 0.5 here. So T plus or minus of delta T is equal to what? So 40 minus of 18, 22 plus or minus of what? So 22 plus or minus of, so 0.5 plus of 0.3. So that is 0.8 here. So look at here, in case of that measuring that rise in temperature, T plus or minus of delta T is equal to 22 plus or minus of 0.8. So rise in temperature is 22 degrees Celsius. So delta of T represents that error. So total error is 0.8 degrees Celsius. So this is the way to find out that rise in temperature. So look at here. So in case of combination of errors, so errors in case of addition as well as subtraction we got. So in next video, so we will be discussing about that errors in case of multiplication as well as in case of division here.